All right, so section 8.6 is on solving quadratic systems. So it says, just as we did in previous chapters, you can find intersection points for systems of equations. So previously, remember, we found like systems of equations early in the year, where we had one line intersecting another line, and they intersected in a single point. Or if they were right on top of each other, it was an infinite number of points. Or if they were parallel, then they didn't intersect at all. Do we all remember this? Okay, so we don't always have lines intersecting with lines. Sometimes we have like a parabola intersecting with a circle. Like there can be other things like that. So there can be more than one point that are in common to systems of equations. Okay, so it says, for instance, consider a circle intersecting a parabola. What is the maximum number of solutions that we could have? What do you guys think? 2. So we could have something like a circle intersecting a parabola. Ah, we get a 4. So if that parabola dipped down a little bit more, could we have any more than 4? No. Yeah, so 4 is the most. So how many solutions could I have? Could I have one solution? Think about how we could draw one solution. Yeah, maybe the parabola just barely touches it. That would be one solution. 2, we already did, so this is 2 solutions. Could we have 3 solutions? Yeah, so how would I draw the 3 solutions? Exactly, if the bottom of the parabola just barely touches that circle, that would be 3 solutions, or we could have 4 solutions. What about no solutions? Could that happen? Yeah, so if we have our circle and then the parabola doesn't intersect it at all. So we could have 0 solutions all the way to 4 solutions. Okay, and that's how most of these are. So most of them are 0 solutions to 4 solutions. And we'll talk about ones that have only 2 versus 4 and so on. So we're going to do several of these examples. So it says, solve the following systems. There may be more than one solution. Verify your solutions with Grapher or a graphing calculator. You could also check your solutions in both of the original equations. So identifying what is what. So the first one I think you guys know. X squared plus y squared equals 25. Do you guys know what shape that is? Yeah, it's a circle, right? It's centered at 0, 0. The radius is 5, right? We know that equation. This next one isn't quite set up like a circle. We have a 4 and we have a 9, but it's not set equal to 1 here. And remember, the ellipse equations were set equal to 1. Could we get it set equal to 1? Yeah, we could just divide by 145, right? And then we could reduce things out. That's actually an ellipse. So when we have something with our x squared and our y squared and these aren't the same numbers, that's going to be an ellipse equation if there's a plus. If there was a minus, what would we have? A hyperbola, right? So lots of different possibilities. So we have a circle intersecting an ellipse. What's the maximum number of solutions we can have if we have a circle intersecting an ellipse? Can you see it in your head? We could have 4 solutions, exactly. So our maximum number of solutions here is 4. All right, so we solve it just like we did before. Substitution, elimination, one of those choices. Okay, I personally like elimination. So I'm going to multiply this top equation by -4. So when I do, I get negative 4x squared minus 4y squared equals negative 100. So when I add straight down, my x squared terms are going to go away. So my negative 4x squared and my 4x squared, they go away. I have negative 4y squared plus 9y squared. So I get 5y squared equals 45. I divide by 5 and get y squared equals 9. So I get y equals what? 3? Just 3? Plus or minus. Good. So we have plus or minus 3. Okay, so those are 2 possibilities for the y value. We need to find the x values that go with it. So we can say, okay, well, what if y is equal to 3? And what if y is equal to negative 3? And we go back into either equation. I typically pick the one that looks simpler, smaller numbers. So I would pick the x squared plus y squared equals 25. And I'm going to plug in. So I have x squared plus 3 squared equals 25. So I have x squared plus 9 equals 25. I subtract my 9 over, and I take the square root, and I get plus or minus 4. So right now I have 2 solutions so far. Okay, so I have the y value of 3 goes with positive 4 for x. The y value of 3 goes with negative 4 for x. So we write it like this. Negative 4, comma 3, and positive 4, comma 3. Those are 2 of our solutions. Do we see that? X and then y. And then we plug into the y minus 3, or y equals negative 3, so I get x squared plus. Do we think this is going to give the same solutions or different solutions? it's going to give the same. Yeah, we're also going to get plus or minus 4 for that one. Do you guys see? Because negative 3 squared is going to give us 9. Positive 9. So that means that I could also have negative 4 comma negative 3 and negative 4 comma, or not negative 4, positive 4 comma negative 3. So those are our 4 solutions.
Couldn't you just infer those solutions from the answers for x and y?
What do you mean?
Like since x is plus or minus 4 and y plus or minus 3, can you just...
Yeah, so sometimes if you have all of these solutions, so notice how we have 4 where it was all different versions of the pluses or minuses, you can shortcut it and you can write plus or minus 4 comma plus or minus 3. I would just be very careful with that because sometimes it's only 2 solutions. And I'm going to talk about ones that aren't going to work for 4 solutions. This one worked because of the x squared and y squareds, but in ones where we have maybe a parabola that only has like an x squared and not a y squared as well, sometimes there's only 2 solutions. Okay, so when I'm making that choice on whether I'm plugging it into one of these equations, I always plug it into whatever equation would give me less solutions. And we'll do an example like that. Okay, so let's try this one. Do you guys want to try it on your own first? So, do you guys know the 2 shapes? What's your guess? Yep, both of them are ellipse equations. So we can have a maximum of 4. So go ahead and try that. So we are going to, looks like it's easiest to multiply through by a -1. Either the top or bottom, it doesn't matter. So let's multiply the top so I don't have to deal with a negative for the x squareds. So I'm going to have negative 4x squared minus 25y squared equals negative 41. So I typically show that step where I multiply through by a -1, just so I don't have to worry about the signs. Like I have all those signs changed because sometimes we make simple mistakes. So when we do this, the 25y squared and negative 25y squared go away. So we get 32x squared equals 169 minus 41, so 128, is that right? What did you get when you divided by 32? 4. So you should have plus or minus 2. Did you guys all get x is plus or minus 2? Good. So then we go back to either equation. So like I said, I typically pick the ones with a little bit smaller of numbers. Doesn't matter in this case because I have both x squared and y squared. And I'm going to plug in x equals plus or minus 2. So if I plug in 2 and -2, am I going to get different answers or the same answers? Can you guys tell? Yeah, you're going to get the same. So sometimes I kind of shortcut it and I don't do the thing where I do both of them. And instead I just plug in plus or minus 2 in for x at the same time. So I write it like with parentheses, plus or minus 2. So that's totally fine as long as you see that you are going to get the same answers because of the squaring. So if I had positive 2 and I squared it, I get 4. But if I had -2 and I square it, I also get 4. So I have 4 times 4, which is 16. So plus 25y squared equals 41. I'm going to subtract 16. So I get 25y squared equals 25. So I get y squared equals 1. So y equals plus or minus 1. So what this means is every combination of those numbers goes together. So I could have 2 and 1. I could have -2 and -1, 2 and -1. What did I leave out? -2 and positive -1? I don't know. So you can have every version of those. So if you want to shortcut it like we just talked about, you could write plus or minus 2 comma plus or minus 1. That would be totally fine. Or you can write out the 4 different combinations. Okay? Yeah?
Which one of these is a circle? Or are either?
Both of them are the ellipse equations. Because the numbers, and we'll talk about this with a little chart that we're going to have on the back, these numbers are not the same, like that 4 and 25. So when I divide through by 41, it's where I'm going to have a different a squared and b squared. But if a and b are the same for an ellipse, you go out to the right and up the same amount, right and left and up and down, don't you just make a circle? So when they're the same, that's a circle. All right, so here we go. So what are the shapes that we have here? So the first one, what do you think? A parabola. Is it up and down? Right and left? Which direction does it open? Yeah, so it's going to be opening actually to the right, I think. Yeah, because it's a positive 2, not a negative. Yep. And then how about the other one? No, it's not a circle. It's a line. Yeah, it's linear. It's a line. Remember, y equals mx plus b? I tricked you. It's not one of the conic sections. It's just a line. Okay, so what are the maximum number of solutions that I can have with a parabola intersecting a line? 2. So if we get 4 solutions, we've done something wrong. So we need to keep that in the back of our mind. So max number of solutions equals 2. You guys know the symbol for number, right? I did that the other day when tutoring, and my student was like, what's that? It's number. It's not a hashtag. I accept pound sign as well. It's no longer being called the pound sign. Hashtag number, whatever. So, yes, it's a number. So the max number of solutions is 2. So let's figure out the solutions. So this time, probably not the greatest if we add straight down, if we do that elimination method, right? Do you guys see that? Not the best. Okay, so we can do substitution or elimination. So let's say I solve this bottom equation for either x or y. It doesn't matter. So let's say I solve it for x. I would have 3 minus y like that. I'm just going to subtract the y over. So when I replace, I'm going to replace this x with what it's equal to. It's equal to 3 minus y. So I get a new equation of 3 minus y equals 2 times y plus 1 squared minus 6. And you may not like solving it, might cause fear in your hearts solving something like this, but you are able to solve this. We've done this since at least chapter 5, right? We've done this. Okay, so we're going to y plus 1 squared. What do I do? Y plus 1 squared. Is it y squared plus 1? No. Do we all know that? Yes. You're not going to owe me $1 like that Sycamore teacher I was telling you about? No? Maybe? I tutored someone and I asked him the other day about if he got his dollars back, and he was like, I didn't get them back. I thought she gave them back. I don't know. All right, so I have y plus 1 times y plus 1, and we FOIL it out. So you're going to have y squared plus 1y plus another 1y plus 1. So we're going to have 3 minus y equals 2, and then we have y squared, and then we had 1y plus 1y, so I'm going to write plus 2y plus 1 minus 6. Okay, and I continue to simplify. I multiply the 2n. So I'm going to have 2y squared plus 4y plus 2. And then minus the 6. Are you seeing where this is leading? As I said, you don't always like it, but you know how to do this. We're going to get everything on one side. We have y squareds and we have y's. So we get everything on one side and we're going to factor. So I'm going to have 2y squared. I'm going to add the y over so I get plus 5y. I have 2 minus 6, which is negative 4, and then I'm going to subtract the 3 over. So I have negative 4, and then I subtract 3, so I'm going to get minus 7. Still good? If you don't know how to factor, you can always do quadratic formula, but I'm sure you all are factoring pros now, right? You can do this. So we know it's for sure 2y and y. And there are only choices for the last number. They need to multiply to be negative 7, so it's going to be 7 and 1, and they're going to be opposite signs. Okay, think about where we're putting the 7 and where we're putting the 1. The 1 goes on the right side here with the y, yep, and the 7 goes here. Because we know that our outer and inner, those swoops need to combine to be that 5y. So the 7 is a positive 7y, and the outer swoop is a negative 2y. So see how we have 7y and minus 2y, so we get our 5y. Okay, almost done. We're going to set each of those equal to 0. So I have 2y plus 7 equals 0, and I get y minus 1 equals 0. So I definitely have y equals 1. Can you guys do the next two steps together? What's our other y value? Negative 7 over 2. So it's not as nice as those ellipse ones, is it? Kind of gross. Okay, we definitely have to plug both of these in. There's no shortcuts in saying, oh, plus or minus. Plug both of them in at once. Okay, so what I told you guys a little bit ago is I said, we know that we have a maximum of 2 solutions. If I plug my y values in to the top, I have that squared, I don't know. We could get more than one solution. We want just 2 answers. So an answer to go with this y value, and an answer to go with this y value. So that way we have 2 points. The best thing to do in this situation is to not go to the more complicated one with higher degrees, right, with y squared. See, it has y squared. Instead, go to the one that has y to the first, x to the first. Okay, that will give you the correct number of answers. So we're going to go to the x plus y equals 3. And we're going to plug in there. So I'm going to start with my -7 over 2. I kind of underline it so I know I'm plugging that in. And I'm going to plug it into x plus y equals 3. So I'm going to have x minus 7 over 2 equals 3. You can clear your fractions if you want to. You can multiply everything by 2, or you can just add the 7 over 2 over. So we have 3 added to 7 over 2. So we have 6 over 2 plus 7 over 2, right? I'm getting common denominators. So we get a total of 13 over 2. So the first point we have is the lovely 13 over 2 comma -7 over 2. Answers aren't always nice. A lot of textbooks these days are all like x equals 5, x equals 1. Sometimes it's 13 over 2 comma -7 over 2. True story. All right, so let's try the next one. So if I have y equals 1, this one will be nicer. Can you guys see what this one is already? Yep, it's 2. So we get 2 comma 1 is the other solution. So those are our 2 solutions. Okay, can I scroll back up? Okay, so how about the next one? So we have x squared plus y squared equals 100. Shape? Circle. Gloria, what's my center? What's my radius? Yep, do we all know that? Feel pretty good with circles? All right, how about the next one? Eric, what do you think? Nope, close. If it had been an x the first it would be.
Oh, it's x squared.
Close. Not a hyperbola. She's saying, oh, there's a minus in there. Maybe it's a hyperbola.
Yeah.
It is a parabola. How do I know for sure it's a parabola? Only one thing is squared, right? The other one's not squared. Okay, those are the only ones that don't have like x squared and y squared. So we have a parabola that's an up and down parabola, and we have a circle. So our max number of solutions, 4. So we could have 4 solutions on this one. All right, so we go back through and we do exactly the same thing. Now, this one, it's not one where we have x squared and y squared. I also would not do elimination. I would probably do substitution. So notice how we have x squared here. Can you solve this first equation for x squared maybe? Yeah, x squared is equal to 100 minus y squared, right? So we're going to take that 100 minus y squared and we're going to replace that x squared. Sorry, lots of arrows going on. Do you guys understand what I'm saying? So my new equation is going to be y equals 1/2, and x squared is replaced with 100 minus y squared minus 26. Okay, let me multiply it out. So I can multiply that 1/2 in. I would have y equals 50 minus 1/2 y squared minus 26, which is fine. But if you guys really don't like that fraction, what could we do now? Not square, multiply by 2, right? Yeah. So I can multiply everything through by 2. So I'm going to have 2y equals 100 minus y squared minus 52. 26 times 2. Okay, and then I'm going to have to get everything on one side. So a lot of times I try to get my y squared to be positive if I'm choosing a side to get it on. It doesn't matter. So if I had that negative y squared, that's fine. Then I'm going to subtract the 2y over to the right side of the equation. Like subtracting this over. And then I have 100 minus 52, which is 48. So I'm going to have plus 48. And then you can divide by the -1, or you can just pull that -1 to the front. It doesn't matter. And this one's much easier to factor. So Luke, what do you think? How's this factor? you did the other way, so you're like, no. All right, anybody have this factored? Yeah, what do you got, Michael? 8 and 6, yep. And you're saying the negative goes with the 6 and the 8 is positive? Yep, so check your outer and inner swoops. Do they combine to be positive 2? Yep, we're good. So they combine to be positive 2. Y. So I get y equals negative 8 and I get y equals 6. Luke, was your way easier? Okay. Sometimes you have to choose your battles on solving these systems of equations with conic sections. Sometimes it does get very messy. So if that happens on your homework and you're like, oh my god, this is ridiculous, why would Mrs. Cox ask me to do this? Then think, maybe I should have solved for the other variable. Sometimes it is messy. All right, so I got negative 8 and I got 6. So I'm going to go back up to those two equations, and I'm going to pick whichever one has the least degree. I know they have x squared, they're degree 2. But which one do you think I should plug it in for? Top one or bottom equation? Yep, actually the bottom. Do you see why the bottom? The bottom didn't have the y squared, right? It just had y. So if I plug into the top, sometimes I get too many solutions, and that's where you would need to check your solutions. I haven't really been checking. I've been lazy. Really, I should go back into both equations to check that all of the points work. Okay, but if you do it correctly, if you pick the correct equation, you don't have to do that check step. Okay, so if you don't do it on your test, make sure you do it right. So we're going to plug it into the bottom equation because I don't have a y squared, I just have a y. Okay, so I'm going to plug in negative 8. And I'm going to get 1/2 x squared minus 26. So when I add the 26 over, what do I get, 18? So 18 equals 1/2 x squared. I'm going to multiply by 2, so I get 36 equals x squared. So I get x equals plus or minus 6. So those two x values both go with negative 8. So you could write it like plus or minus 6, comma, negative 8. You could write it like that. But for these, I typically write them as separate points, just so you can see it. So we have, oops. So we have negative 6, comma, negative 8, and we have positive 6, comma, negative 8. Okay. And then I'm going to plug in the 6. So same thing. So I have 6 equals 1/2 x squared minus 26. So I'm going to add the 26 over. Did I write that correctly? It's just a gross, well, no, it's not gross. Okay, so I'm going to get 32 equals 1/2 x squared. I divide by 1/2, which is the same as multiplying by 2. So I get 64 equals x squared, so I get x equals plus or minus 8. So my solutions are then 8, comma, 6, and negative 8, comma, negative 6. No, hang on. Negative 8, comma, 6. Oh, you missed out on a bonus point. Okay. Got it? Yes? All right. Sorry, that's a lot, I know. This is a long section. All right, so let's do the next little bit. So this says, write the following conic sections in standard form by completing the square. Did you guys remember how to do this on your study guide when you guys were doing the study guide? Kind of. Okay, so if we're going to complete the square, remember I told you the best way to set it up is to get your x's together, get your y's together, and get your number on the other side. Okay? So luckily that's how this is pretty much set up, except I want to subtract that 28 over, or that, yeah, the 28. So I'm going to have negative 28 over there. Okay. So also, in order to complete the square, we need to have a 1x squared and a 1y squared. Okay. This one's actually, they're all divisible by 4. I could make it simpler. Should we just divide everything by 4? Do you guys see how everything's divisible by 4? 4, 8, 8, negative 48, negative 28. Let's say we hadn't noticed that. Let's just go with it with 4. Okay. So I'm going to pull out from the x terms whatever number is in front of x squared, because I want that to be a 1x squared. So I'm going to pull a 4 out. So I'm going to do 4, and then I have x squared plus 2x. Okay, and then I do the same thing with the y. So I'm going to pull out the 8, and then I have y squared minus 6y. And it's all equal to negative 28. Yep. You got it. All right, now we complete the square. So we have it and square it. So I'm going to take the b value and I divide it by 2 and I square it. So I'm going to have 2 over 2 squared, which is 1, and that 1 goes right in here. And then I do the same thing with this one. So I take that number, I divide it by 2, and I square it. Have it and square it. So I get negative 3 squared, which is 9. So I add a 9 here. We do. So do I put a 1 and a 9 on the other side? Almost. I'm not actually adding 1 and adding 9 to the left side of the equation. What did I really add? To 1, what did I really add to this side? Anybody know? Ah, 4. Is that Logan? Yeah, how'd you get 4, Logan?
4 times 1.
4 times 1, right? I've now made this side heavier by 4. Do you guys see? Because it was multiplied by that. 4 times 1. Okay, so you can do, there's something cheesy that you can remember this. So basically this is a box and this is a box. We've talked about those little boxes. On conic sections we have a house that we're adding to each side. You can do the house if you want to. I don't care. But basically you need to remember that we have the 4 and the 8 that we pulled out. And so when I add a 1 and I add a 9, I'm not actually adding 1 and 9. I'm actually adding 4 and 72. Do you see that? So the house sometimes helps you remember those other factors. You can do that if you want to. I stole it from another teacher. I tutored someone that did that, and I was like, I like the little house. I wonder if my students will remember. Do you guys think you'll remember? No? We'll see. So I get 4, and then that's now a perfect square. And I'm going to have negative 28 plus 4 plus 72 that I'm adding. And this factors into x plus 1, and this factors into y minus 3. We're almost there. I know it doesn't look like it. You guys are like, oh, what is going on here? Okay, what do I get when I add all those numbers together on the right-hand side? Did anybody do that? 80 minus 24. Is it 48? Hang on. 80? No. Okay, hang on. Maybe it is. I added 4 and 72 and got 80. That's not good, is it? 72 and 4 makes 76, right? And then minus 28, so it is 48. Okay. We are almost there. Do you guys at least know what conic section it is? Not a circle. Because we had the 4 in front of the x squared and we had the 8 in front of the y squared. It's an ellipse. So if I'm trying to get it in the standard form for an ellipse, we always had equals 1 on the right-hand side. So what we're going to do is we're going to divide everything through by 48. And when we do, the 4 and the 48 reduce out. So we're going to have x plus 1 squared all over what number? 12. Good. And then I'm going to have y minus 3 squared over 6, right? Because 8 and 48 reduce to 1 over 6. And then equals 1. So it is an ellipse. It's just your a and your b value aren't like super nice. A is equal to the square root of 12 and b is equal to the square root of 6. 2 root 3 and 6. Root 6. All right, do you understand that? Should we do one more? You guys get it? Okay, so we're going to get everything on one side. So I'm going to get my x's together. Doesn't matter which side you get them on. I'm actually going to get them on the right side because I like that to be a positive 4x squared. So I have 4x squared plus 16x. I'm going to subtract that 9y squared over. I'm going to have my plus 54y. And then I'm going to equal it all to 29. So I'm going to keep that 29 on the left-hand side. So I just rearrange things. So like the 9y squared went to the right. I added the 16x. Okay, so again, we pull out that common factor of 4, and we write x squared plus 4x. We pull out that negative 9, and we write y squared minus 6y. It's all equal to 29. And then we go from there. So we complete the square. So what number goes here and what number goes here? 4. And what number goes on the other side? 9. And so we add, on the left-hand side, we add 16. 4 times 4. Right, that was 16. And then negative 9 times 9. Negative 81, right? So we add all of that on there. So we get 4 times x plus 2 squared minus 9 times y minus 3 squared equals 29 plus 16. Oh man, I got to do all this mental math again. What is this? 45 minus 81, negative 36. Did you guys get that? Now we divide by negative 36. And when we do, we get positive 1 equals negative x plus 2 squared over 9. So I put that negative out front. And positive y minus 3 squared over 4. What shape is this? It's a hyperbola. Do you see? Good, Gloria. Because it's really y. I'm going to put the y's first and then put the minus in between it, right? So I have y minus 3 squared over 4 minus x plus 2 squared over 9. That's all equal to 1. It's a hyperbola. Because I had that minus that was here, and it was kind of weird. We never had like a negative out front. It was always like positive x squared minus y squared, or, you know, so I rearranged them. So that was a hyperbola, and the last one was the ellipse. And then really quickly, we're not going to do the next example, but I'm going to kind of flash forward to this. There is a chart, so if you had everything all multiplied out and it was in this standard form, you can use this chart. So you can say, oh, it's a parabola if either I don't have an x squared or I don't have a y squared, right? If I only had one x squared or y squared term. And it's a circle if my a value and my c value are the same, because when I divide out by that number, I'm going to get the same a value and b value on the bottom, right? Like the a squared plus b squared on the bottom. And it's an ellipse if I have the same sign. So if I had x squared plus y squared. But it's a hyperbola if they had opposite signs. Okay, so you can use that for the next two, but we'll just skip those. Okay? All right, let me pass out your homework really quickly. Sorry, I went a little bit over.